And so, if I did plug in this answer as well for A, 161.3, if I do the sine of 161.3, that will also give me 0.3214, or very close to it because it's a rounded answer. So understand that if you are talking about trig ratios or angles all the way around between 0 and 360, which it says in the question, this will always give you two answers whenever you're dealing with any of these. So for instance, let's take a look at this one. Cos of A is equal to negative 0.5804. Now, again, if I take a look at the cast rule, cos A is equal to a negative number. Where is cos negative? Cos is negative here, and it's also negative here. Okay? And so if cos is negative there and there, if I bring cos to the other side and take the cos inverse of 0.5804, if I do that, and again I have a calculator number 2, so I'm going to be doing 0.5804, and I do cos inverse, I'm going to get 54, negative. So I have cos of 0.5804, and if I take the cos inverse, I'm going to get 125.5. Now, is this one of the correct answers? Yes, it is. This is the answer in quadrant number 2. And if I did the cos of 125.5, it should give me this number, negative 0.5804, or very close to it because this is rounded. Now, how do I find the answer in this quadrant? Now, in order to find out answers, you always have to talk about from the x-axis. The x-axis is 0 degrees, 180 degrees on this part of the x-axis, or 360. Always. Why? Because we always draw these triangles straight to the x-axis, so we're always going to relate these things to the x-axis. How do I end up in this quadrant using this number and one of these numbers, either 0, 360, or 180? If I used 180, if I add 125.5, it's going to be too big. It's going to end up in this quadrant, so no good. The only way I can add up and get in this quadrant is if I took 360 and moved backwards by 125. So there's one of my answers. My second answer will be 360 minus 125.5. And if I do that, I'm going to get A is equal to, this is going to be 234.5, I believe. 234.5, yes. So 234.5 is my second answer. That angle would be in this quadrant here. And if I did the cos of 234.5, it would also give me negative 0.5804. Okay? My last one's a little tricky. My last one deals with cotangent of A. So cotangent of A is equal to that. Now, this is not even something we know how to deal with. I do know, as a fraction, this is 1.8421 over 1. Cotangent is the reciprocal of tan. Therefore, if cotangent's this, tan is its reciprocal. Tan A would be equal to this. And so really, I'm trying to figure out this. So, looking at this thing here, and using my cast rule, tan theta is equal to a positive divided by a positive is a positive. So tan theta is equal to a positive number. Where is tan positive in these four quadrants? There's two instances. Tan is positive there, and tan is positive there. So I'm looking for an angle that's this big, and I'm also looking for an angle that's in this quadrant, that big. Okay? Now, if I go to solve for A, if I do tan inverse of 1 over 1.8421, and I go to do this thing, again, I have a calculator number 2, so I'm going to have to do 1 divided by 1.8421, and then I will take the tan inverse of it, and this will give me 28.5 degrees. So 28.5 degrees is definitely one of my answers. That's the answer that's in quadrant number 1. How do I find the answer that's in quadrant number 3? Again, in order to find any other answers, I always relate to the x-axis. In order to end up in quadrant 3, I can take 180 and add 28.5 to it. That will allow me to be in quadrant 3. So 180 plus 28.5, that will give me 208.5. So this is my second answer. Again, if I plugged in tan of 28.5, it's going to give me this number, whatever that number is. And if I did tan of 208.5, it will also give that number. So from now on, your calculator does not know how to distinguish between two different answers for angles. Okay, so you have to understand that when you're doing sine A is equal to a positive number, there are two instances where sine is positive. Sine is positive in quadrant 1 and in quadrant 2. Therefore, you may have an acute angle and also an obtuse angle. Your calculator does not know the difference between the angle of 18.7 and 161.3 when you're dealing with sine. And you can verify that because if you plugged in 18.7 here, it's going to give